Hello and welcome to my lecture on JavaScript. JavaScript was invented in 1995 by Brendan Eich while he was working at the Netscape Corporation. And he sort of invented the first prototype of it in 10 days. It was invented in a great hurry, and it was really designed to be a language that was very approachable, that people sort of view source in their browsers and figure things out, and it would make programming available to lots and lots of people. It eventually became standardized as what's called ECMAScript. So you'll hear it sometimes referred to as JavaScript and other times referred to as ECMAScript. So basically, if we take a look at a document, we got some HTML. It is interspersed with the HTML, which is really different from PHP because we sort of have the less than question mark PHP. That switches to server-side code, but this is not server-side. This is actually run in the browser. So the PHP code, if it has JavaScript in it, simply emits this, and then as the browser is reading the page that it's reading, it's like, oh wait, I've got to switch into code. And so this is a HTML tag, and it actually comes back to the browser and is run in the browser. And so we intersperse the JavaScript in with the rest of the HTML. Now, JavaScript looks a lot different in between the script and the /script tags because it itself is a programming language. And so it's got for loops and all this stuff. And so we flip back and forth. Now, an important thing, just sort of looking at this bit of code right here, this is all interpreted in order. So the browser is like, oh, I saw a paragraph, out comes a paragraph, right? And then it hits this JavaScript and document.write. Document is an object inside of JavaScript that is the access to the actual sort of not the screen, but the backing document that's behind the screen. So document.write with a P tag, this is actual HTML. This actually produces output HTML. And it happens between one paragraph and second paragraph because that's where it happens. The noScript tag is in the situation where the browser doesn't support JavaScript. These days, it's less and less common for browsers to not support JavaScript. Used to be that when JavaScript first came out, there was sort of a debate as to whether or not you support JavaScript, but most full-featured websites demand JavaScript at this point. There might be some other thing like noScript, if you're talking to a web scraper or a web crawler or something like that. So this noScript tag is a way for you to print something out in the case of if the JavaScript is not enabled on the browser that you're sending it to. But basically, we start in script and we end in /script, and then we put some code in the language JavaScript, and that's what we're going to talk about today. So one of the first things I always like to do when I am programming is how to get a debug statement. Okay, and the alert function takes as a parameter a single string, and it prints it out. So here's a very simple bit of JavaScript. The browser sort of runs this. Oops, hang on. Turn the scribbler back on. The browser kind of runs this, and it stops. And depending on your browser, it may actually stop when in the middle while the page is still displaying. So let's take a look at this particular one. Let me clear this and go and run this one. Here's the sample code. We'll run this first one. We already saw that one. Make this just a little bigger here. And so you see this little thing is still spinning. Right over here it's still spinning. And that's because it's sort of still processing the page. And the alert has actually completely stopped the JavaScript. So the thing that's going to happen right after the alert won't happen until I press OK, and then it finishes. Okay, so the alert stops right now, and it's really stopping the interpretation of this page. So alert is it doesn't just print out output, but it stops JavaScript processing. So it's a pretty strong form of debugging, if that makes any sense. And so alert's just an executable statement. There are three ways that you can put JavaScript into a document. One is inline within the document using the script tag. You can also put it on things like on-click methods, on things like hrefs, etc. or you can include a whole file. We'll see all of these examples. So this is some code that we've sort of been playing with all along, but now it is time to sort of understand what's going on here. So this is an anchor tag that is this tag right here. And we have an onClick method. So this is within the anchor tag, right? And it says when someone clicks on this anchor tag, I want to run this JavaScript right here. So the bit in between double quotes is JavaScript. And JavaScript can use single quotes or double quotes as strings. So we tend to reserve the double quotes for HTML. So onClick equals double quote something, double quote, that's HTML. And then quote, high quote, single quotes in this case, is some JavaScript, and we're calling alert. Now, return false has to do with, normally if you were to click on an href, it would actually follow that link, okay? But if you say return false, it won't follow the link, and it'll just run this code and not follow the link, okay? So let's take a look at that one. So if I click, it's going to actually run the JavaScript rather than doing what it normally would do. And if you recall, it would go to jso1.htm, but it's not going to because we did the return false. Okay. So return false is the way to indicate that we don't actually want to do what normally would have happened if the click happened. So you can do both the onClick method and then let the tag do what it normally would do, or you can say I'm taking over and doing that. So this is just one form where we're putting JavaScript right on a tag. So here's another way to do it, and so this one we showed before where we just did a script tag and an end script tag and then had document write. You might see something like this. In HTML5, we tend not to do this, but this is validation to make sure that the JavaScript passes a strict HTML4 validation, but that's less important as we're moving to HTML5. So we talked about this one. And then the third way to do this is to actually use the same script tag and say, I would like to load this file. And this then script.js has to be a file that has some content in it. And in this case, we just have one line of JavaScript. We don't have a script tag. It's just JavaScript itself. It knows that it's JavaScript by the fact that we're inlining it. And so that's as if we typed all that stuff here. Now, this is kind of a silly little example. It actually just moves that document right into the file. But that's another form of including JavaScript that you will commonly see. So syntax errors in JavaScript are a little bit different. I mean, we can make mistakes. It's a programming language. But the problem is that most of the time you're using a JavaScript page that you did not write, and you're just using, Twitter. And if there's a JavaScript error on a Twitter page, you as the Twitter user, it doesn't do much good for you to be told that there's a JavaScript error because you can't fix it. Syntax error, missing semicolon, who knows what it's going to be. So the browsers tend to be very, very silent about any kind of a JavaScript error, but the code dies. Sometimes there's a little red icon that shows up in the lower left-hand corner. So here's just an example of a bit of bad JavaScript where we're just going to have a double quote that starts and ends in a single quote. So that's a syntax error. And what we will see is that this will run, it will die here, so this code doesn't finish, but then it actually gives up on that script block and then continues, and you'll see that this one will run later. Okay, so let's go ahead and show this. In JSO5. Oops. So it did not tell us anything about that first syntax error, but it didn't run that second alert, and then it actually finishes. Okay. So, like I said, the end user is really not supposed to see the error, but we as a developer need to look for errors. And so as we're writing JavaScript, you instinctively, something won't work. You'll make a change and it won't work, and your brain's got to go like, oh, wait, I made an error. I've got to actually explicitly look for it. And so there are developer modes in all of these browsers. I'll play with the Chrome one here. So let's take a look at how you turn on developer mode. And sometimes you have to enable this little message to just show up. But at the end of the day, I can like to view JavaScript console, and I'm going to hit refresh, and you will sort of see what's going on here. It runs, but I see the error, and I can even click right here, and I can see the exact place that the error happens. So increasingly, these browsers all have nice debugger modes in them, and I've just popped up a debugger, and it's got this little thing, and I can look at the console, I can look at the code, and go back and forth. And so this is, can I make that a little bigger? Yeah. So this is a useful thing, and you as a developer, you'll tend to often just leave this sitting down here at the bottom when you're working on code all the time, where it's like, you know, I just leave this on all the time. You kind of do it with console, and you run it, and you see something like, oh, wait, and then you know how to go look for that error. Okay? So that's very important, because there's no good way to see these things unless you've got this console turned on. Sometimes your browser will say, go look up JavaScript errors, but it really wants to hide these from end users. You as the developer of the website have to get this stuff right. So alert is kind of a blunt instrument in that it stops running the code. And sometimes you have a loop or something. You want to put some debugging in it. And so these debuggers have added a console.log method. And you can pass in a string, and you can console log all kinds of stuff. And so basically what you can do with the debugger turned on is you say, you know, console.log, and it'll come out in the log. And so this same console.log that we were seeing allows you to see things. And it just runs. And so that console.log is a very useful thing, and it allows you to, even inside of a loop or inside of an event or an onClick method, to be logging stuff without stopping. If you do an alert, it stops. But if you do a console log, it just streams by in the debugger window. And if the end user doesn't see this, only developers might see it. So I tend to, in some of my sites, you can go look at them, and you'll see the console talking, and you can see, you know, a play-by-play of what's going on inside of one of my sites. Now, depending on the browser, the console object may or may not always be there. Sometimes it's there when the debugger's on. Sometimes it's not there when the debugger's off. So my favorite thing to do is, whenever I'm going to do a console log, I say window.console, which won't cause an error, and so that means that if the console exists, then I will call console.log. This is just a real succinct way of saying that, window.console and console.log. Another way to do it, you can look up all kinds of ways to deal with console.log. This is my preferred way to do it, but you can also just, if the console function doesn't exist, console variable doesn't exist, it sort of sets that up and sets a log function, but this is my favorite way to do that. So the debugger, as we mentioned, is a great tool for debugging JavaScript. You can pause the debugger, so let me show you how to do that. Let me go back. You can pause code. Oh, sorry, got to clear that. Pause code. So here's JavaScript 01, right? And I can look at the source. And I can put a breakpoint here by clicking right there. So I now have a breakpoint at that point. Now, the page is already run, so once I set the breakpoint, I've got to hit refresh once to load the page. Now that it knows where the breakpoint is supposed to be, it'll run up and stop at the breakpoint. Okay, and so now it is paused in the debugger. You can see that it's paused in the debugger. You see this little spinny guy, meaning the page isn't done loading yet, because we've stopped it. And we can look at variables and global variables. There's all kinds of stuff that we can look at. Document, object, model, all kinds of things. And I just click right here to continue the debugger. And so the page completes. Now that's a very, very, very simple introduction to using the JavaScript debugger, but it's very, very valuable. And you'll get used to how this all works after a while. So let's now talk a little bit about the JavaScript programming language. So JavaScript is a programming language. And it's just like other languages, it has its little quirky things. So JavaScript was informed by lots of languages that came before it. It has two basic forms of comments. One is a double slash, which is like a C++ form of a comment that says from here to the end of the line. And you can also have multi-line comments that start with / to end, and that's like a C language comment, which, this is what we like. We like both single-line comments and multi-line comments in JavaScript, and that's quite nice. White space and new lines do not matter, although we rigorously indent to make our code easier to read. Statements end in semicolon. There's places you can leave the semicolon off, but it's a little different than Java and C and other C-like languages, but most programmers just program as if they were in Java and put all the semicolons in, and don't try to remember the complex rules as to when you don't need semicolons. So here's a good example of white space that simply does not matter, right? Here is, x equals 3 plus 5 times 4. It doesn't matter if there's a new line or lots of white space. The same is true if there's a new line. It's as if that white space, a new line, doesn't exist. Variable names are pretty typical. The only thing that's kind of weird is you can have $signs. They're optional. I'm not sure exactly quite why JavaScript allowed this. I think sometimes language designers are trying to appeal to people coming from different languages, and so maybe people coming from PHP or Perl might have felt more comfortable. The problem is that if you're in a file where you're mixing PHP and JavaScript, it's sort of considered tacky to use the $sign in your JavaScript code. You want to really use that in your PHP code. PHP requires $sign. JavaScript allows it, but again, we tend not to do it. Okay? But other than that, it's pretty much standard stuff. Start with a letter, case matters, underscore. We tend to use underscores for variables that are internal, you don't just have random underscore variables unless it's sort of like global variables or internal variables or some kind of a special variable. String constants are nice. Single quotes and double quotes kind of work the same. You have things like new lines that work in either single quotes or double quotes. Again, not all languages are similar like this. Single quotes, but they're equivalent. But what we tend to do is we tend to use single quotes in our JavaScript constants unless we absolutely need to use double quotes, because we want to use double quotes for the HTML elements. And sometimes you're writing JavaScript that's writing HTML. And so it's nice to sort of, in your mind, just say if it's double quote, we're using an HTML. If it's a single quote, it's a JavaScript string constant. And it uses standard C like backslash either in single quote or double quoted strings. Clicking the wrong place to clear the screen, but we got this screen cleared. Numbers, floating point, integers, just exactly what you would expect. We'll talk a little bit in another lecture about more detail about arrays, but if you just have a standard array, the syntax is pretty natural. They're zero-based and use the index operator with square brackets, and so kind of like lists and integer indexed arrays in PHP as well. Standard operators, plus, minus, modulo. We have our post increment, which is, k plus plus is, pull out the value for k and then add 1. I'm using the console here. I'm actually just typing these into the console. K plus plus says, give me the old value of k and add 1, and that's why k is 4. This is a predecrement, which means take out the 4, subtract 1, put it back in, and give me the post-decrement value. So, but don't use those too much. But we do use modulo, and we use plus, minus, and those guys like that. So operators are pretty basic. Like many C-like languages, we have the side effect operators, plus equals, minus equals, star equals, standard side effect operators. Comparison operators are very much like C and very much like PHP, in that there's also a triple equals as well as a double equals. where there's less conversion going on, and the triple equals is kind of like equivalent to, where there's no type conversion going on, much like PHP actually. Logical operators, again, like PHP, double and is and, double ampersand is and, double vertical bar is or, and not is exclamation point. String concatenation. This is probably the part when I switch from one language to another that drives me nuts. I like how PHP uses the dot, but JavaScript uses the Java and other languages more common syntax of plus for concatenation. And it does do aggressive type conversion where needed, and so there's no like string function or anything like that that you might use in Python. You concatenate a string in an integer, and it's like, oh, I'll turn that integer into a string for you, and it concatenates. Okay. Variables, of course, have types. It is a little counterintuitive. Like, for example, here we're adding a string and a number. In PHP, we would expect that to be a number, but in JavaScript, it's a string. Here we're doing a multiplication, so that's going to turn that into a number and then add 10 to it, so we get a number. And then you will see in JavaScript this thing called nan. Okay, nan is a floating point concept called not a number. And that usually you get it by dividing by 0 or doing something else illegal. And you'll see it often in dynamic web pages where you'll see nan and you're like, oh, that means JavaScript's in action, and probably divided by 0 or something like that. Nan is sticky. So like if x ends up being Fred times 1, it has no idea what to do with that, although PHP would know what to do with that. Fred times 1 is not a number, but then not a number stays not a number if I can add 1 to it. Not a number plus 1 is still not a number. So it's kind of a sticky value. Once you end up with a computation that's not a number, there is no way to do more computations to that value and change it back to a number. It does variable conversion. It's a little bit different. We can also end up with infinity by dividing by 0 by mistake. There is an isNan function, and so we can do these kinds of things, but in general we just sort of avoid doing silly things like multiplying Fred by 1 or dividing an integer by 0 in JavaScript. So these are just some functions that you can play with. There is an operator called typeof, which basically tells you what kind of a thing you've got, and it returns a string. And so type of y, because, you know, that's crazy. Y is equal to quote WHY question mark, and it is a string. And so you can check, and you can also find out if something is undefined by looking at the type of an undefined variable. Functions are as you would expect. The keyword is function, and you got a function name followed by your arguments. And of course the arguments are really just temporary placeholders so that they kind of correspond to the call, first and second thing, and they sort of work. And there's a return, and the return value becomes the residual in the expression from whence it was called. That part all looks pretty straightforward. The thing that's not straightforward, and I find it really annoying, really annoying, because in this respect, JavaScript works differently than virtually every other language that I'm used to, that any of us are used to, and that is if a variable exists, like this GL variable, if that variable exists before the function sort of is defined, then this GL is a global GL. Not because I called it GL, but just because it goes like, oh, does GL exist? And it does, so I'll just hook those two things together. So if you look at this code, right, it sets GL to 123. This function is defined that changes GL to 456. We call the function, and then we print out GL at the end. And the global GL, the outer GL, the GL outside the function, has been changed to 456 because this hooks up with that global variable. Okay? Counterintuitive. In every other sane language, this GL would be a local GL within that function, right? But that's not particularly sane. So we have to sort of have a way of overriding that. In any sane language, you'd have to say global to make it escape the bonds of the function. But in JavaScript, we use the var keyword to force it to be local. So you'll see var all the time. Var says make this a local copy, and even if there is a global version of it, then this is local. And that's why when this code runs, the global 123 is separate from the local 123, and it stays 123 globally. The whole purpose of JavaScript is to mess with the browser's document object model. So JavaScript was built to run in the browser. It was built to manipulate the text that is the page. So the document model is like this thing that we can make changes to, and then the browser is rendering whatever is in the document object model. And so it manipulates the HTML document, and it is a object-oriented syntax where we say document.this, .this, 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 that we can hierarchically go and we can find all kinds of things. But the problem is the document object models aren't universal. It's universal that there is a document object model, and if you know the structure of the document object model for a particular browser, the syntax to get to a piece of a page is well understood. And so we can read and write this thing. And so it's, document.head.title.something, or document.body.h1. And so there's this hierarchical structure that represents the page. But unfortunately, the shape of this picture is different for different browsers. So not all browsers represent their page exactly the same. The exact same HTML would produce a different document object model in different browsers. So you have to test your code over and over and over on each browser. If you are doing you're actually sort of just going straight down the document object model to find a form or a header one or something that's in there. And so you end up with these bugs. This is just a bug in Sakai, an open source project I work on, and all of a sudden you're just always seeing these Internet Explorer bugs because, if you're going deep into the code and using the document object model and you test it on Firefox, you test it on Chrome, and you don't test it on IE, then it blows up and you get all these ugly bugs. And so using the document object model directly is generally kind of tacky, right? It's just life's too short to deal with the vagaries of the difference between document object models. So the first thing that they added to JavaScript to make life a little simpler was a method called getElementById. And that allows you to mark a particular piece of the DOM with an ID tag. And that's why there can only be one ID tag anywhere in it. And then you can say, I'm not going to look down hierarchically to find this thing. Just go find the thing that has an ID of Fred and give me back that thing and let me manipulate that thing. So it's a way to, in effect, very simply query the document object model and find something by an ID tag. And so here's an example. So here is a string Chuck. It's wrapped in a span tag, and the span has an ID of person. Okay? And so here in my JavaScript, I say document. Everything starts with document. GetElementById, and then I give the ID that I'm looking for. And then that basically looks through the whole page, and it finds the thing that has the ID of person. And then, let me clear this. Then this little expression right here is this tag. So you basically have got yourself a handle. ST is the variable, this ST variable. That ST variable is a handle to that little part. Okay? And then you can do things. And we can do stuff to the outer part, the tag, and everything. But if we just want this HTML, we have to say, give me the inner HTML. So I say .inner HTML, and that dives into the tag and pulls out the actual HTML text. That's the child of that tag. And I can print that out, and I can also change it, right? I can also change it. So I can put it on the document, getElementId person.innerHTML equals Joseph. Well, that is an assignment statement that's going to overwrite this part of the document object model and change it. And I have a couple log statements. So let's play with this particular one right here. This is JS12. Okay, so if we recall, it goes in, it finds the ID tag of person, then it prints out, let's switch to console. I can't, oh wait. Let me switch to console here. I mean, once the alert's up, I can't switch, right? Because the alert has taken over the whole browser. So I'm going to switch to console so I can watch it in console, and then I'm going to clear the console, and then I'm going to press refresh so that I can sort of watch it all happen in the console. Okay, so it looked up the span with ID equals person, pulled out the inner HTML, it both logged it in console.log, and it did it in an alert box. Okay, now this browser is frozen. This browser is frozen because the alert box is up, and it's not going to do anything until we press OK. So I'll press OK, which means the JavaScript is going to start back up again. If you recall what it does, it first puts out a log that shows what kind of a thing that object is, that ST object, and then it changed it to Joseph. And you'll notice that it changed it to Joseph. Literally, my JavaScript code changed the document object model, and the browser is always rendering whatever's in the document object model. So my JavaScript changed the document object model, the browser's just poof, rendered it. So I'll do this in faster motion. So the original HTML had Chuck. We looked that thing up. As soon as I hit this OK, it's going to change it to Joseph, and it just changes to Joseph. Okay? So if I didn't have the alert, it would happen instantaneously. It would happen so fast you wouldn't see it. And I can use console.log to kind of keep track of stuff, right? And so you can sort of work through this thing and see all the stuff that's happening. I make it go in slow motion by putting this alert in. I could also use the debugger and a breakpoint if I wanted to see that. But I just want to stop it. So this is looking it up, pulling stuff out, and logging it, and then it alerts to stop it mostly, and then it changes it and continues on. Yeah. So here's another one that basically is sort of combining an on-click. And so what's going on here is I have two links. It's probably easier just for me to show you how this works. This is JS 13. Oh. This is JS 13. Okay, so if I look, the word stuff is in here. Oops. So I have a span, ID equals stuff, and I have an on-click, the word back and forth, right? So I do a document get element ID stuff, inner HTML equals the string back. If I click on that, then I return false. Remember, you got to return false. And then if you click on forth, it's going to change that text to be forth. So what I'm doing is I'm overwriting this stuff, right? I'm grabbing it, and I'm going to change it to back. Then I'm going to change it to forth. I'm going to change it to back, and then I'm going to change it to forth. And this is all done on these clicks. But it starts out coming from the server with stuff there, right? Because that's what's in there in the first place. Then I click on this href, and it changes the DOM to be back. And I click on this href and it changes it to be forth. Okay? This won't be very exciting. I click on back, it looks it up in onClick, it looks it up and then changes it to the word back. Oh, sorry. There we go. Click on back, I click on forth. I actually don't have any JavaScript to reset it back to stuff unless, of course, I hit refresh, and then it pulls another copy from the server, and it's its original form. These are just going back and forth and changing it. Okay? Fascinating. Hit the back and forth. Fascinating. Okay, and so that's basically causing things to happen as response to clicks. The previous example, we just sort of had straight line code that ran. Now we're going to see stuff that happens by clicks. Now, in an upcoming chapter/lecture, we will talk about jQuery. And this get element ID is sort of old school. jQuery is a library that was designed originally to greatly reduce the confusion between browsers, and we tend to use jQuery a lot. Lots of people just sort of assume jQuery now, but it is a library, and we will cover that in the future. But I want you to also see, before we do jQuery, I want you to see how we did it before jQuery existed, because you will see that kind of code, the getElementById code. We tend not to do too much without jQuery, but sometimes you don't want that library and you want to do a real simple thing, so you kind of fall back to this code. Everything I've shown you so far does not require any libraries. Once you have jQuery, your JavaScript can be a lot simpler and more elegant. Okay? So thanks. See you in the next lecture.